Hi everyone, and welcome to this next session and video where I'll be introducing Git to you. So Git is a new piece of software and we really think that it's worthwhile to learn it. And in this video, I will be introducing you what Git actually is. And in the later ones, we'll cover how to use it and demonstrate it and much more. And of course, also in the in-person session. But first off, a few prerequisites. So also in preparation for the session on Friday, we'd ask you to please follow these three guides or do these three things. So first of all is that you please install Git, and we've linked and I'll upload of course the slides for this, so you can just click the links. You don't have to like type it out or anything. You can also just Google this information, but like there's some really nice guides here made by, also shout out to Malika Ile, who is here at the LMU actually, and create these really lovely guides on how to use Git in RStudio, which quite a bit of this material will be based upon. So I'd first ask you to please install Git on your machines, and you can just do this by going to the Git website and downloading it from there. Then second, to please create an account on GitHub. We'll cover what GitHub is in a bit more detail later on, but first I'll just like register, or if you already have an account, you're fine. And then last, you will have to authenticate with GitHub to interact with it through Git. And that part is a bit complicated. So this is the most technical part of this whole thing, right? Like signing up for this website and like downloading Git takes like, I don't know, 2 minutes or 5. But setting up this authentication is a bit more cumbersome, but we'd still ask you to try this at home, please. It's not going to take forever. It's not like super crazy. And if you do encounter issues, it's perfectly fine. And we can just talk about this in class, and we'll talk about it in class. So this last one, maybe give it a try at home. If you're getting super confused, it's fine, and we'll like just talk about it. But it's good to get this done once, and then you're like set. Okay, with these prerequisites out of the way, what is it Git actually? So, can I click it? Yes. So Git is a version control system. And what does that mean? Well, you can kind of already version, right? It keeps track of different versions, and these versions are files. So what Git specifically does is that it looks at the changes in your files, it records all these changes over time, and is able to give you a full history of the files in a directory that you track with Git, when you first started tracking it with Git, and then like all the way to now. And it's very similar in that way to kind of the track changes mode, right? You have this like switch in Microsoft Word or LibreOffice, the free alternatives, or also in Google Docs. It just works behind the scenes, that you can go back and see old versions of a file. It's also a bit similar to undo, but I feel like this track changes really does it more justice. And to visualize this a bit, so let's think, for example, this is an R script you're currently working on, and you're writing on it, and then you change this last line in the file, which is symbolized by this, to this, right? So you have these three, but like this one is changed. And then Git, if you in between save the state with Git, it's only going to look at this change. So it saves this previous version, then it only saves the change, and then it knows how to arrive at this last version, right? Because you can just add the change. Similar, if we add 3 more lines at the bottom of the document of the R script, we end up with this final file, basically, and Git will again only look at the changes. We'll only compare these 2 versions, and we'll see, oh, these 3 lines are new, so I'll just track these, which of course makes it very efficient, because just with all these changes, you can go back in time, but you're not going to need to save all the states of your file. You can just change the differences and then kind of add the differences to the file, and that way go back and forth in time, which is super, super powerful, but more on that later. But why even do this, right? Like, what's the benefit of this? And I think this comic does it a really good, does it justice, kind of. I hope it's big enough on your screens. But it's like a classic thing, right? Like, I think everyone who's ever written like a thesis or like a term paper or something, you create like all these different versions, right? You start off with like the final version, you're done. You get some feedback from your professor, from your teacher. Okay, you make like final version 2, and it keeps on going until you like end up with this like crazy long version that you edited all these times. It's really hard to keep track of, and it's really confusing. And with Git, this becomes like super streamlined, super neat. You could basically go back to the first version that you had all the way to like the latest. It's always like the normal document name. You don't need to like do any weird things. So it's really, really convenient in that regard. Which brings me to the next point, which is the strengths and weaknesses of Git, just so you have like a bit of an idea before we dive into the nitty gritty. So the strengths. First, because we want to stay optimistic, I guess. One thing that's really, really nice with Git is that it's very hard to lose files. So once you have something in Git, you have it tracked in Git, and you accidentally delete the file, you could always recover it if you don't do like crazy things and delete like the whole folder or something. Yeah, I mean, it's just, you can just add it along, you can do crazy things, and you can always restore a previous state. So it's really, really nice to save data. And sometimes just for that reason alone, like if I have an important project I'm working on, sometimes I just put it in Git and like under version control, just to be safe that I don't lose the data. That's already worth it, like just this one point. Then second, it's also really, really good for collaboration. We'll only briefly touch upon it in this course just because it gets a bit complicated, and we'll only have this one session on it. But this is also really one of its superpowers. And this is also one of the reasons why, for example, in industry, like this Git really is the de facto standard. And this is another good point I want to highlight, that if you plan to do anything with data, with R, as an actual job, you will have to use Git. Like there's no way around it nowadays. Like every company uses it almost, or at least they should. Else it's like also almost a red flag. Once you get to a certain scale, once you have multiple people working on analysis for anything, you will need Git and GitHub, and it's just so good to already have at least like an idea of it. Although we'll only like scratch the surface in this course. So yeah, let me just highlight this real quick. Then third, it's like really, really fast, which is great. You can have lots of changes and Git will just blaze through it and immediately detect just the changes, which is super convenient. You get this huge history where you can just go back to like the very beginning of your project. And also if you get into a new project, you can see how the project evolved, who changed what, which person to ask, right? Like Git is going to tell you for every line of the code, who changed this code and when did they do it. This way you can go back, see maybe why something changed, how it changed over time, who is the responsible person to ask, right? If you're in like a new organization, it's like a very complicated analysis, you can tell, oh yeah, this person did this change. Now I can just ask them why. It's great for reproducibility. So it's also a standard way of like sharing your R code. If you actually want to make like a public analysis or something. If you publish a paper, it's also one of the standard ways of like sharing your whole analysis code. So also in this space is like amazing. And of course, it's also great because it tracks these things over time. So you can also, if someone did like a complicated analysis, you can follow this along, how it kind of developed. But of course, there's also some downsides. So briefly on the weaknesses of Git, because it's not like all good. Like there's some things that you need to keep in mind where like it might not be worth using it. And the first big thing, and that's of course something we'll hopefully be able to address at least a bit in this course, is that it can be a bit complicated to use, especially at first. Like it's a bit of a tough learning curve where like you start off really steep, and then like you have what you need, and you can use it, and you're like super happy, and then like learn it bit by bit. But this first cliff, it can be like a bit rough, and we'll really hope to get you beyond it in this course. But that's like, yeah, it takes some getting used to get into like the flow of how to use it best. The history does take up file space, so I mean, if it's just R code, it's really not a big deal. But in general, it's a thing, right? Like it does cost like additional storage space, and especially if you have binary files, because that's like the next downside. So anything that's not a text file really. So of course, all programming code and everything that's always text files, are Markdown is perfectly fine, but images already, they're like okay-ish. But also, I mean, Word documents, PDFs, these are all not really supported by Git. What do I mean by that? So for any text or like R file, for example, Git can actually look at it line by line. And this doesn't work that well for like any binary documents, so like PDFs. Word documents as well are binary because there's all this formatting. So Git cannot tell the differences there on like a line by line level. So it cannot tell you the changes. It's just going to look at the file as a whole and tell you, oh yeah, this file is different. And then of course this like really efficient way of storing data kind of goes away. And data, I shouldn't be using data in this way. Of storing these changes, it kind of goes away. So then, for example, if you're tracking a Word document, you can track this in Git. It works perfectly fine. You get all the benefits. It's just that it's going to take up more space, and every change is just going to save the whole document. So this whole like efficiency thing kind of goes away a bit. And part of this, and another reason or another problem with Git is that it also struggles a bit with larger files. So if you have like really, really big files, these can overwhelm Git a bit, and then it does get a bit slow because it can change it, searches the whole file for changes, right? And that of course can take up like quite some time. And that is the reason why Git is actually not that great for storing data itself. So if you have a data set, if it's small, you can put it in Git. If it's big, GitHub might not be the best solution. And there's solutions for it. We'll not go really into detail here just because it's a bit off topic. Feel free to ask me if you really like come across this problem, you want to know the solutions. Happy to talk about it, also in class or something. We're not going to go down this rabbit hole right now, but often it makes sense to actually only track small data sets in Git and not like bigger ones. And last, you do need to explicitly use it. So it's not that you just like kind of take off this thing in the background and it's just going to track all this for you, but you actually need to put in a bit of work. You need to like manually tell it, oh yeah, like these are the changes I want to keep track of, like these files. And every time you want to like save the or commit, that's the word, but we'll get into that, the changes, you will have to explicitly do so. Which, I don't know, this is like a mixed thing. On the one hand, yeah, it does take effort and it makes it a bit more like less hands off. On the other hand, in the long run, it's really much better because you end up with like a much better and more understandable history. So it kind of forces you to do it better, but it does take some time. So it's good to know. But in general, in my opinion, the strengths far, far, far outweigh the weaknesses. And like I said already, this has become an industry standard at this point. So if you do anything where you'll touch code at like a company, you will work in Git. Like 99% of companies use this right now, and it's really a big standard. And I mean, for employment later on, like it's a huge asset to already have some exposure to this. Okay, now continuing a bit more, there's roughly 2 ways of using Git, and you might have already had like a bit of exposure to this because it's also similar to R, because we're kind of writing this code and like executing it in this R console. And similar to Git, like Git originally is a command line program. So I've written CLI here, which stands for command line interface, which just means that you use Git in a terminal. So you can see how this would look on the left here, where you just kind of write in some command, press enter, it's going to execute it and give you back text. Like it's all text-based. And here, for example, you can already see that I put in like a Git command in the terminal. It gave me back some stuff. We're not going to worry about this now. But it's all like text-based. It's super fast, which is really nice. And this is the original form of Git. But because Git is so popular, there were also many, many graphical interfaces designed around it, which makes it just much, much nicer to use, in my opinion at least. There's some hardcore people who like only use it via the command line. I'm a bit more like on the graphical side. This is something everyone needs to decide for themselves. But in this course, just due to like lack of time, we'll focus a bit on the graphical side. And because I feel like, especially for beginners, it makes things a bit easier, right? Like you don't need to remember all the command names. You don't need to type them out. You can just click buttons to make it do the things that you want. And so on the right side, you can see here the graphical interface, or one of them, for Git. And again, like the actual nitty-gritty details, we'll do this in a separate video, probably the next one, where I will show you in like a live demo how I use Git to track some changes. Okay, and maybe you've already guessed it, but both of these screenshots actually come from RStudio. So weirdly enough, RStudio has both. It has this command line interface, and the graphical user interface. And just to briefly show you where to locate these, and this might be different depending on your configuration. I always get confused again because I changed some of my RStudio settings. But so this is a screenshot from my setup. And so most of this should be the same for you, but it might be that some of these quadrants here, like these top left, top right, bottom left, bottom right, quadrants might be different for you. So just as a heads up. But like I'll just use my setup because this is what I have and I don't remember what the RStudio defaults were. So for me, you will find the terminal that has the command line interface in the top right. So we can zoom in on this. And there you see, so this is right next to the console. Console is where the R code gets evaluated. So whenever you run like R code, and it also has this text interface, right? It gets sent to the console, and there's also a terminal, which is a bit more of a general piece of software where you can run all sorts of commands, and one of them is Git. So Git is just one of the many programs running in there, basically. And if you want to run any Git command in there, you just write Git and the command. Like I said, we're not going to focus on this, but it's good for you to know that this exists, because for some of the more complicated stuff, you will need it. Like I said, again, not the focus of this course, of this session, just to give you general understanding. So you can then, it's just like a tab. So instead of console, you click on terminal. It's going to open this thing in the working directory. So if you use an RStudio project, it's going to be already in the right directory. And then you can just type your commands if you want to. What we'll rather use is the graphical user interface. And so for that, you'll see that this is next to the environment browser. So this is where all the variables and the data frames that you loaded so far are stored. And so there, one of the tabs is Git. And this might not always be present. And we'll get into this in the next video. So if you haven't told R or like Git that you want to track this directory that you're currently working in, it might not show this, just for like to not confuse you. So you might have to first initialize Git in there, and then it's gonna show you. But again, like we'll get into this. We'll cover upon this in the following video on like actually how to practically use this, just to show you how to locate these things. And then zooming out again. So for this one, it's top right and bottom left. But in general, it's always going to be next to the R console where your code is evaluated, and next to the environment browser where you find all the variables. That's it for this video. Briefed on the graphics we used, and I shall see you in the next.